Okay, hello, good morning. So we were struggling a bit yesterday um, as we were playing around with this external state management that kind of follows the top-down flow of React. So you have external state management, you're using just mutable state, very, very straightforward. But it subscribes to like the root object, and then everything's immutable. When it's reconciling React. So for example, here we have this data state that we're just updating every 100 milliseconds for a second. And then we just expose that to React. Now the issue was we had some stuff that was mutating. And the reason it was mutating, I figured it out, is because of this one. So when we create a proxy, I was just doing a shallow copy, but we had, and typically that's like, well, that's a problem regardless, because when you have this initial state that you're passing into this state function, we need to make that like a full copy, right? Not just a shallow copy, because we are mutating under the hood, but we're making an immutable version of that. And this is because in the external world, you have that mutated state, and then in React, you have that immutable state. So I just had to do a structure clone on it. That was the reason. And that's fine to do. Like when you define state, like you have the initial state, right? So we wouldn't have noticed this if we had like more of an app-like behavior where we would asynchronously get a list of data. But since we had it initially, that's how we detected it. But that's a good thing. Anyways, I actually started playing around with this, and I did some benchmarks. And it's very interesting stuff. We're gonna have some fun with this, and I think we're gonna learn a lot. So what's the current state of things? So first of all, let's just do a plain, we need a vite file open here, vite config. So let's do no compiler, and let's see, how do we actually build up our state now? We're using immutable state. Yes, and we're gonna do some additional logging. We're gonna see like console.log app. And since we're like rendering the data table directly, we can just go in and we can say table. The thing that I'm curious about is, so what I learned is that it's using this React table thing, which is why the table didn't update. It's because we have to manually, what the hell? Oh, yeah. We have to actually set the data again to keep it up to date. But I have no idea how this actually works. Because is there a data, is there like a table provider or something here? Yeah, because you're going through, I would imagine it being like super efficient. Yeah, so there are a couple of things I do not quite understand. Let's see, UI, drop down menu. Okay. Okay, then I think I see. Do we have like one per? Where's the actual? I just have to understand. So the reviewer wrote down get all columns, and how does it render the rows? Oh, here we are. Table row. Yeah, so each of them, there's a table row component. Where's that coming from? Oh, yeah. Okay, cool. So that's why it works. Okay. Okay, so let's get started with this. So we're gonna bring up the, yeah. we're gonna bring up the profiler, and then we're gonna do our first. So what we're doing now is that we're using immutable top-down state. So I'm gonna reload, start a profiler, and then I'm gonna stop it immediately, and then it should process the data. And then you can see we have this. Maybe we should put it at the bottom here instead, or let's make it a little bit bigger. Oh, I need this to be bigger. Let's see, maybe we should try at the bottom. Okay, let's do this instead. So you can see here that like it has like a lot of, so every 100 milliseconds, I think, it has like this very inefficient, like look at this, render takes, yeah, so committed at 1.1, yeah, about 100 milliseconds, but it also spends like almost 100 milliseconds, sometimes more than 100 milliseconds just rendering the thing, right? So this is, and all of the time is spent in the actual data table. I thought he was in a good mood today, but I was wrong. 2 seconds. Pardon? Nei, men det går ikke det, Oskar. Du får si fra hvis du vil spille noe annet. Spille mot verden. Skal du spille mot verden? No, let's see how well this goes. So all the time is spent in the data table. So what we're gonna do now is that we're just gonna throw the React compiler at it and see what happens. So we're gonna go into read config and let's just add the compiler. And this is the nice thing about ShadCN is that the React compiler will actually compile those as well. So let's run it again. It takes a little bit of time the first time. I think this is the biggest worry with the React compiler is that it's slow. But yeah, okay, so we're gonna refresh the page again, and then we're gonna hit enter, stop. I think I have to click the page to actually process the data. So now you see that this thing looks much, much better. But there's still like some concerning renders, right? So these are like the 100 millisecond spread about like, yeah. But still, even here, it took like 150 milliseconds. It's very interesting. So I ran this through production as well, and that kind of halvens the render time. But still, it's like, ideally it should only be 60 milliseconds, right? So even though it's better, the question is it like good enough? Kind of weird though, because on my other computer, it took like, what was it? Well, it was around 50 milliseconds, yeah. Anyways, so this did improve it, but every time I do an update, there is like concerns. But then I can change this, and we can do the, oh, did I import observer plugin, Bonsify, bubble plugin, and then we need to change out our data thing here. We need to use reactive instead. Cool. So now we're gonna do this instead. So this is the actual, like, here we have observers around all components. All components are memo, and like targeted reconciliation. Oh, there's nothing on the page. What did I do? Oh, sorry. Cannot read properties of undefined. What happened now? Did I build it? Oh, fucking Rocket League. It keeps... it just freezes. It's so fucking annoying. It's such an old game. They haven't fixed it. It's insane. Just 2 seconds. Yeah, it's insane. Like, it never freezes during like local play, but online play just freezes. And the worst thing is that you get banned from the game for like 20, sometimes 40 minutes because the game freezes up. It's insane. Yeah, why didn't it work? I'm also very curious why it takes so much time to load up the thing. Rows.length. I am confused. Why doesn't this work? Oh, of course. Sorry, I forgot. sorry. So data is data. Sorry about that. Okay. So let's go to the profiler again. Let's refresh. Let's stop it. And now, like, it's just so much better, right? So definitely, like, doing this targeted reconciliation, it makes you wonder, right? When you see how slow React is in its default behavior, how the React compiler, yes, it does help you, but it's like observation is just so much better. And I'm having a hard time concluding on what to take from this. So like the thing is that we're doing like a full table update every 100 milliseconds for 1 second. Yeah. Which is not common, right? But the point is, if the user is interacting when it takes a lot of time to render, like that's the thing, right? So I did some chat GPTing and I was experiencing like 30 milliseconds, right, to render the table. And as ChatGPT says, that's not necessarily a bad thing. Like that, it's not a problem. The problem is if the user is interacting with the page exactly at that time, right? But that's why React has like start transition, for example. So if you do have expensive updates, you can do a start transition, and React will make sure that that's not affected. So if you're typing in an input, that's going to break out of rendering the table, and you'll have this super smooth experience. So this is the thing I'm trying to get to terms with is, okay, so we try the React compiler on what I consider to be like the most challenging reconciliation, which are like tables, like complex tables that has a lot of updates, which is not the typical experience, right? So I want to come to terms with that the React compiler just handles this really, really well. And then if you were to like get into some kind of situation where you're like updating stuff a lot and there's risk of interaction in between, you can just do a start transition on that update. Just 2 seconds. Ja. Nei, det går ikke ennå. Det var 20 minutter. Det går litt tid til. Jeg kan si fra. Gjør det. Sett på klokka. Nei, pappa holder på med noe, skjønner du. Yeah, so I want to conclude with that. Oh, what's scheduler yield? Is that like a library kind of thing, or? Oh, or is it a browser thing? Yeah. I think when you... Yeah, because they're bringing the scheduler as a browser API, right? Or do they already have it? Yeah, task scheduling. Did it come from React? Or was it inspired by React, having this scheduler? The yield method of the scheduler is used for yielding to the main thread during a task and continuing execution. Yeah, so the thing about React that we kind of have to keep in mind is that these are people that are working like very low level, and they're working like with web standards and the future of like browsers and all of this, and they're working towards something. Like we're in the middle of like just having concurrent mode introduced and these new hooks that's gonna like help you deal with performance and all this stuff. I can't take this. He's in a shitty mood. Fuck. I like when I have had one day where I've been able to sit and stream and the kids have kind of been doing their own stuff. One freaking, well, not one day even, like 20 minutes. That's all I've gotten. Like I can't do what I want to do at home, having the kids at home. And I'm getting fucking sick and tired of it. And I know, and the moment this is gonna change is when the kids aren't home. Like they're always with their friends. And then I'm gonna miss them so much. And it's so annoying having this friction. God damn it. Just 2 seconds. Oskar, kan ikke du heller gå opp til mamma? Kan dere ta den tur ut? Ok? Ja, men nå merker jeg at du begynner å bli sutrete, men pappa blir veldig, veldig irritert. Fordi nå holder jeg på med noe jeg synes er artig, og så hører jeg masse sutring herfra, og det orker jeg ikke å høre på. Ok? Nå må du enten spille det her, til du er lei av det, og så kan du gå opp til mamma. Ok, så kan du spille med sånn mot verden etterpå i dag. Yeah, React Chrome came up with this. Yeah, it's interesting. But at the same time, it's like looking at the observation model, right? How insanely performant it is. Like, do we really need all this stuff? Yeah, I like that's the thing that's still poking at me. It's coming to terms with like embracing React and this top-down immutable approach. I have to like ignore that from my perspective. It's like it's just a bad model. And everyone else realizes it, right? Vue has always done this. Svelte is doing this. Solid is doing this. Angular is doing like observation based. Everyone's doing that because it is more performant. Yeah, it bugs the hell out of me. And so many times I try to like, oh, if I could just replace React and just build observation into it and like just have a virtual DOM, right? And then just build this stuff into it. But the problem is that the ecosystem of React, like there's so many amazing tools around React, which kind of keeps you a prisoner. So if you were ever to build, like you have things like Preact and Inferno, that are kind of also fixing the performance issues of React. But at the same time, it's also very exciting to be part of React because there's so much stuff happening. Yeah, I really, yeah, coming to terms with it is the thing. Like, I would much rather want to be like embracing React and support React and find solutions that's compatible with React's mental model than like keep bashing on it. And just as I just said, like I think they chose the wrong like paradigm for state. They should have gone with observation. Like just put that aside. But that needs some. I need to do some soul searching. I think to get there. Um, but what's interesting at the end of the day, what's interesting is doing this version of Bonsify which is compatible with React and the React compiler. Because as we talked about, if you're gonna use the React compiler, in combination with reactivity systems, you're gonna have a hard time because the React compiler is gonna try to memorize all these mutable references. So it's gonna completely. It's probably gonna break a lot of stuff. But then I still worry about the speed of the React compiler. But maybe Vite can fix that. Like Vite is exceptionally efficient. I don't care that much about build times, but the developer experience is incredibly important. Yeah. Okay. So I think this is kind of the conclusion. I think because there are only two options. Either you have to create a reactive system that sits on top of React with its own computed, its own effect, its own everything, and that just sits on top of React, right? So you can like, okay, maybe that's an interesting drawing. So like, what is the matrix of solutions there? Oh, look at this. So you have So you have external, all external reactive. Yeah, this doesn't make any sense. But the point is that either you make everything, so you add a reactive, external reactive system. So all the reactivity that you express happens externally from React, right? So you just completely separate React from this reactive paradigm. Now, what this means is that you don't need a React compiler, because this is going to be so efficient at rendering anyways that you don't actually need it. Unless you're actually, well, yeah, but maybe you're doing some local component stuff that has performance issues, so you kind of have to use these traditional use memo hooks and use callback to kind of handle that. But if there's anything you need to like cache or like derive or whatever, that's like actual reactive state, you have to do everything external. Like do everything external. Reactive or external reactive. Should I call it that? What am I trying to say? Because this Bonsify thing isn't reactive in the same sense. You're kind of just subscribing. Okay, so it's external state management. Yeah, and then you have like, yeah, I wish React would have an observation mode. Where it would actually like as you say, signals is a native thing. Yeah, it would solve everything, I think. Like natively observe native signals. It would solve, at least it would be an, it's definitely an alternative approach. Yeah, I just keep coming back to that. But anyways, so you can do reactive externally. So you can do reactive externally, or you can do reactive. Like what I'm trying to say is like preact signals is a good example. So you can use preact signals only externally, or you can also start using preact signals inside components. Internally. Hæ? Ikke helt ennå, snart. Wow, someone just tried to got a text message about a package and they're trying to it's amazing. Trying to get me to go into a URL which is obviously fake. Let's see. Yeah, so preact signals is probably the best example of this. So if you're gonna do like reactive state management, in my mind, you should only do it externally, and you should not use the React compiler. But that means that you're building up your state management in a way that's that needs to be aware of your UI, because your UI dictates how you should derive the state, right? And then you have to, because any derived cached state needs to happen in that reactive layer, or you have to start introducing special hooks in the components. But then you're, to me, that's not good at all, because then you have useState with useSignal, and then the state from useState doesn't work with useComputed, and you have to know that a prop is like a signal, and it's like, it's, to me, that's like, then that's just bad. Like, React would have to have that natively for that to make sense. But then do immutable externally. Yeah, this matrix doesn't make any sense. Sorry. But then you can do immutable externally, and you can use the React compiler. Yeah, so for me, there's really two options. Either you do reactive, do okay, so external, reactive, do everything there. And then external, immutable, do whatever there. This is the best I'm able to express. So the point, and this is the struggle. So when we do reactive externally, it adds some frictions to it. Because in some sense, you want to like build a whole. So I like the perspective of UI as an implementation detail, but that's not true, because it's not just having pure state and having pure UI. There's something intertwining them, and that is the derived thing. So you have state, you have derived UI state, and then you have the UI. You don't only have state. So like, this is what I mean. This is how we often think about external state management and UI, but this isn't the real truth. It's derived. Yeah, okay, now it's coming together. You have state, you have derived UI state, and then you have the UI. The question is, where the fuck do you put this stuff? Who owns this? Is it the component, or is it your external state management? Who owns it? And that's kind of what we're doing here now, is if you want to go reactive, the state has to own it. But if you go immutable on your external state store, the UI can own it, like the components can own it. And there's something very promising about like even in Redux, you have like use selectors and stuff like that. But what you should be able to do with the React compiler is just take in your state and just in the component, just derive the thing you want to show in the UI directly. And then it will just be optimized. And if you want to share that derived state with other pieces of UI or other components, you would just lift it up, right? Create a hook higher up in the component tree, and then share it with nested components. So when I've been working on this family Scrum map, that's the thing that's been throwing me off all the time. It's like, where do I put this stuff? And we were like going back and forward and back and forward and back and forward. Like, no, we're going to do only state in the external layer, but then where the hell do I derive? And then we couldn't derive it because it was a mutable state mixed with React. So that wouldn't work. So yeah, so it's not just a technical decision. It's like if you're creating an external state management solution, of course you need a way to like we have this reactive function or the state function, you need something like that. But if you're doing it like actual reactive, you also need to have a computed function there. Not because, how should I put it? Well, not because you technically need to derive external state. It's because you're forced to derive UI state in that layer because it's not compatible to do so in React. But that shifts the whole mental model of your external state store because it isn't just state, it's UI state, or at least derived UI state as well. And that's not like a bad thing. It's just a different model. But the problem though is having derived UI state at the external layer is the subscriptions. Because, for example, if you define some derived UI state on, for example, a to-do, and then you throw away that to-do, that subscription will stay there. Like it will never be garbage collected. And the reason is if that computed thing isn't explicitly disposed of, the subscription is just going to stay there, especially if that subscription points to some parent state. So a single to-do is deriving some state based on its own state and some parent state. And that parent state will stay forever. But to-do might be thrown away. But now, since that computed state points to some parent state, that's going to stick around forever, even though the to-do itself doesn't. So there, it's a memory leak thing. But I think that could be the interesting thing about the Bonsify project. It's like it could expose two different primitives. It could have, like even if it was just a research thing or an educational thing, it would kind of have these two models. Like it has a mutable reactive thing that uses the Bubble plugin, makes everything observations and memo. You're not going to use the React compiler with this approach. You're going to think about your app like the external state management is your app. It derives all the UI state and everything. And then your components become super, super minimal and simple. And then you have this other primitive, which is a single like immutable subscription at the top, where you use the React compiler, but now you're going to derive your UI state in your actual components. But I wonder if there's a way to, maybe we can discuss this with ChatGPT. So I am reflecting on reactive state management. Normally, state is observed in components with an observation primitive that tracks access to state. But there is also typically a computed primitive. Now, this primitive also has an observation that subscribes to changes of whatever. So the thing is that when you have an observation primitive in a component, you automatically unsubscribe to it when the component unmounts, right? But there is no unmount of state, like when it's external, right? The subscribes to changes to whatever is accessed. The great thing about observation primitives in a component is that they unsubscribe when the component unmounts. But a computed primitive would live externally from React and would not know if the state it I would not know if the state it computes is no longer referential can no longer be referenced. Is there some way to create a computer that is discarded when the way to an observation of a computer that is discarded when the state it wraps can no longer be referenced. For example, if I had a list of to-dos and I want to compute for each to-do, a list of counters. I want to compute for each counter the double of its current count state. How would I make sure that when the counter can no longer be referenced, that the computed observation subscription does not cause a memory leak? Referenced observation. It's just a start of discussion to reflect. But I remember doing this with happy weekend. I just had a rant about being home with the kids, not being able to do what I want to do. It's getting better. It's getting much better, but it's still, I'm looking forward to the day where I can like spend 2 hours just doing a stream and the kids are just doing their own thing. Okay, you're right to be concerned about lingering subscription from computer values that live outside of React's managed lifecycle. That is a common challenge in Reactive state system. Here are a few strategies. Auto disposal based on active. So many reactive libraries implement computer values that only activate. Yeah, when they have active observers. Oh. Oh, that's interesting. Oh, yeah, that's what I did with Impact React as well. The problem though is, oh, that's interesting. Yeah, so that's how you can do it. Yeah, I was more curious about weak references. Store computed values in a weak map where the key is the original state object. Yeah, but computed value, like it needs to dispose of the subscription. Yeah, no, not fine. Yeah, you could use finalization registry as well, because then you can actually run logic. Like you can run the dispose. Yeah, but of course you can base it on how many observers the computer actually has. So it starts subscribing to, yeah, that makes a lot of sense. Okay. What does this mean? So for example, in the family Scrum app, if we were to use Bonsify as its highly optimized mutable state store, it needs to have computed. And the reason it needs to have computed is because it's mutable state. So you can't compute it in components. But that also means you have to extend the mental model of what that external state management is. It's also reaching into derived state for specific pieces of UI. It just has to be like that. So you're kind of like, you could like make two layers. Like you could have like one layer that's like the generic layer, and then you have the actual state you expose to your components, which is like specific to the UI, right? So you kind of like have one state management abstraction consuming another one. So it's basically a model, view model, and view. Yeah. So you have a model layer, you have a view model layer, and then you have your view layer. But instead of thinking about that as like a component, you think about it as like more monolithic, like the whole app in and of itself. Or it needs to have this computed thing, or you can simplify it. You can have a single primitive of state, subscribe to that at the top. It is like, no, you don't put any UI stuff in here. And then it's up to your components to derive the state they need for the UI. And that's much more portable, right? And it also frees you from, I think it's a much simpler, yeah, I don't know. Is it a much simpler model? I think it is a simpler model in the sense that when you build UI, you should have a lot of flexibility. Like that's where you want wiggle room, right? Building UI, building experiences. And if you're gonna sit in this external world and kind of build up everything, and then you go and implement the components, and you have like the perfect interface to build that specific UI, that's great, but that UI is gonna change. Most likely, or it should change. It should at least be able to change efficiently. And now you have to move back into like the external world, and you have to change how you derive state, and you have to make it optimal again. And then also if maybe you want to have a different UI, right? Based on the size of the view. And based on that, you want to derive different state. Like if you do it in components, you can have like, use device hook, right? And then if it's a mobile, you render a component that derives the state in one way. And then if it's not a mobile, you have another component that derives the state in a different way. So yeah. So let's look at the Family Scrum app. Do I have it there? Family Scrum. So for the Family Scrum app, like it would have, if we were to do like the full on like reactive approach, everything here would be we would have like the specific derived state for, okay, so let's do an actual look at an actual app. So this is Family Scrum, right? So here we actually in the state management layer, we're fully reactive. It would have a computed for the count here, would have computed for the count here. It would have a computed for displaying these slides. And going into this list, it would have a computed for the list itself. When you change this, like you could even have like the input itself, when the input changes, yeah, like you would have a computed of the input and the groceries. So you would just have like, this is the list of groceries, which is a computed of all available groceries and the filter. Like you would just put everything in there. And that's how my mental model has been up until like we started working on Code Sandbox version 2. Like Cerebral and Overmind and all these tools are based on that thing. Like just put everything in your external state store and you'll get so much more insight using dev tools and so on and so on. And that's been amazing experiences. But then there's been this pull towards just using React. But what does that mean, just using React? Does that mean, no, let's explore React compiler and still just use React, right? So you just build up your state management higher up and you're still using use state and all of this stuff. And then you go from there. Do you even need external state management? That's the question. And then, yes, you have some quirky primitives like useState with its callback. By default, you have to spread and slice and dice arrays. Or you can use immer, for example, so you don't have to do that. So it's more like you, and then you might have React Query for data fetching and so on and so on. So you're kind of choosing different tools. And that's probably fine. So I guess that's the biggest question I have now. Is there even a room for external state management and make it compatible with the React compiler? Because if you have the React compiler, why even have external state management? That's the question. So I think a better next step would be take the family Scrum app, having one version which is like full on reactive paradigm, put everything in your state management, design that state management for the specific UI you're going to implement, but everything's in that state management. And then we're going to, because I'm also eager to try to implement that computed thing, so we're going to try that. And then compare that to, okay, we're going to have a version of this app which is using the React compiler. And then how would we actually do it then? And then we can even profile it, right? And then we can take a look at that. Because that will be, for me, that would kind of be the ideal solution. Because even now I'm in a discussion at the company I'm working in of like, there's huge performance issues in the app. And then we're talking about like, oh, we should use Surstand or something. Like just use something external and we'll fix that. But there are costs to going external as well, especially when you mix and match them, right? So to me, it's like either... Har du lagat till mig? Nej. Hæ? Få se. Nej. Du, så fin den var.
Her er alle dine bokstaver.
Det er alle mine bokstaver, ja.
Er det det?
Ja, det er det.
Så her står det bare sånn. Og så her, vet du hva det er?
Nei, fortell.
Det her er et stup.
Er det et stup?
Ja.
Å ja.
Kan jeg game nå da?
Vil du game litt?
Ja, men det
Hæ? Ja, pappa holder på fortsatt litt. Men vil du game selv, eller skal du ut på en tur med mamma?
nå vil jeg game selv.
Du gamer litt selv? Ja. Just 2 seconds.
Men kan pappa,
Mhm.
man kan bare være,
Ja, jeg vil gjerne ha den på kontoret mitt.
så viser jeg hvordan den her må bli igjen.
Hæ?
Så viser jeg hvordan skal være.
Ja.
Sånn.
Hæ? Men han der, ja. Perfekt. Tusen takk, Oskar.
Ta den.
Ja.
Da blir jeg hjemme.
Ja, ikke sant. Skal jeg hjelpe deg å starte, da?
Pappa, vi må ha den bakom der.
Nei, det må stå der, skjønner du, for den spiller musikk for meg. Kom an, skal jeg starte den på deg. Oi, unnskyld. Gikk det bra? Hva er det du skal spille av?
Jeg har spyttet der. Er det gamle?
Nei, det går bra. Ellers så har du jo, jeg tror det er gris her.
Ja, vi har den. Å, det.
Men du får det. Der er du. Er du klar? Eller skal vi se. Nei.
Best på best.
Sånn. Lykke til, da. All right. No, it's actually our son, but he's getting a haircut this weekend. And 4-year-olds, they're very what's it called? Andronid. There's a word where it's hard to see if they're like boys or girls. But yeah, thanks regardless. Yeah, it's really interesting. Like, and even a 4-year-old, there's another boy next door here who's always had very long hair, and our 4-year-old doesn't trust us that he's like they're very. It's weird how conscious they become about. Yeah, it's very fascinating. This whole separation of boys and girls. Oh, 17. That sounds great. Do you even remember what it was like when he was younger, like 4 years old? Or do you just have like fond memories? Or do you still remember like any stress? Or, well, it depends on the child and family situation and everything, of course. But yeah. Anyways, it's very interesting how early they start like separating themselves from being like girls and boys. And I wonder like how much of it is us making that apparent to them, because there is this age up to like 3 where it doesn't exist, and then suddenly they become very conscious about it. And but they still play with each other like seamlessly in kindergarten. There's no like, it's more how they express themselves. But at school, when they start school, it's just complete split. Girls play with girls and boys with boys, and it's horrible because there's something about the dynamics of mixing up the I want to use the word biology, like the hormones and chemistry that comes with like having the X and Y chromosomes and their constellations. It's like one of my previous bosses when I was a consultant. He said like we were only guys working at the company, and we couldn't have like, he wanted to make sure that we were about like 50-50 when we had like events, because it was so much nicer. Everyone was behaving like when there was only guys there, the fights would occur and stuff. And that's what's happening at school as well. Like when they start school, they separate boys from girls. Like how conscious it is, I have no idea, but it just happens. And the boys, they just get crazy. They start like fist fights, and it needs to be balanced. But I don't know. It's just my experience with it. What were we talking about? Yes, we're gonna go into Bonsify. We're gonna leave that. It was really fun to build that experiment. So we're gonna keep it around top level notify. Very interesting stuff. Oh. Blah. Git checkout main. Yeah, so it was very interesting stuff, but what we're gonna do is we're rather gonna implement a computed for Bonsify. And then we're gonna go all in. So there is a question now. Okay, we're gonna do something else. We're gonna make all getters computed. So we're still gonna have a single primitive, but we're gonna make all getters computed, so they cache their value. And we're gonna do that by, wait, what did I do? I did, oh. What happened? What did I do? No, close all. Don't save, don't save, don't save, don't save. What did I do? Don't save, don't save. Oh, come on. Did I move like no modules or something? Oh, come on. There's probably like, oh, okay. 6 unsaved. 5, 4, 3, 2, 1. There we go. Wow, that was weird. Okay, so we're gonna introduce a computed, but it's not gonna be exposed as a primitive. It's just gonna be, the getters are gonna be computed. And the reason we didn't do this originally is because it wasn't in my consciousness, like this tension on like the technical challenges and the tension around like where do you derive UI specific state. But it's more, at least at this point, it's like more obvious to me that if you're going to use React Immutable primitives, you have to define that state externally. So as I'm just repeating now. So the scope of external state management kind of increases, which is really a good thing. So it kind of becomes this UI as an implementation. I shouldn't say UI as an implementation detail. I guess components as an implementation detail. Yeah, I think that's a better term, because you are thinking about the UI, right? The actual user interface. I meant React as an implementation detail. That's better. Anyways, so you do that, or if you don't want to do external state management, you want to like build this one app inside React, you want to use the React compiler, you can do that. but mixing and matching them, that's the tension. Yeah. Current statement. Okay, function computed. So let's just start writing some code. So a computed needs to be a signal in and of itself. A signal that tracks signals. That's what it needs to be. I can't even remember how I implemented this. So we have these observers, and what are we doing here? Yeah, it gets its own observer. Okay, anyways, callback is, it returns T, and then this returns T. And then okay, let's just create an observer. We have to start somewhere. And then it's gonna have is dirty true. And then we're gonna start tracking, and this is gonna be a recursive thing, so we need to have like evaluate or something, where it's gonna create the observer. Let's start tracking. It's gonna say value is T, and we can just do CB here. Return value. Oh, sorry, that's not true. We're gonna evaluate. Columns value, return value. Let's see. Is dirty. Is dirty. Is dirty true? Yeah, and then value. Thinking. Yeah, and then we're gonna do is dirty. Is this gonna return a function? I think this needs to return an actual function so it's lazy. Yeah. Okay. Yes, and during its evaluation. Oh, sorry. Stop tracking. And during its evaluation, yes, and then the question is this subscription thing. So this is the thing I'm not quite sure of. Because we can't actually start a subscription here. That's the whole problem. So we kind of need this reverse thing. We really just need to know. Okay, so I think it just needs to be a little bit different in the sense that, but what does this observer track? Like I'm mixing this with the signals implementation, so I'm a little bit observe. Yeah, so it's getting all these targets, right? And then when it notifies, yeah, it changes the snapshot. So I don't think we even need, I think we just need let last snapshot equals 0. And then we're just going to say, I think it's fine, that's 0. And then we're creating this new observer. And just to check, yeah, we have get snapshot. No, how do we know? I wonder if I change the implementation so there isn't like this needs thinking. I don't think I can actually do it with the way it's built now. Because what happens now is that we have this observer. So in a component, we have this observer. It every time anything is being accessed, it's gonna do this observe thing. And it's adding these things to the observations. So it has a list of observations. And then there's this notify. Do I even need to have... Yeah, so the problem is the notify, I think. No, why does this matter? Why do I actually need subscribe? Well, I need this for React. That's true. But I could also do... Does it matter if I subscribe? Does it matter if this observer has all the references to these other things? Yeah. So if these other things aren't there anymore... This is wrecking my brain. This is wrecking my brain. You know what? We can do it in a different way. So, what's gonna happen here is that this could rather have... Okay, we're gonna change this. So what we're gonna do, we're gonna have an observer. So this is gonna be the observer for this computed. And then we're gonna say observer track, stop tracking whenever we evaluate this thing. And then if we're trying to access something here, we have an existing observer. So what we can do is we can just take the observations of this observer and we can bring it, we can push it into the existing observer. So what's going to happen is like ideally it would just put can an observer put another observer? Could that work? Oh, maybe I could just add it. So what if we had observers of an observer? Right? That's what a computed is. It's an observer. So okay, so what would happen? So this thing runs through, it doesn't have a subscription in and of itself, but it has these observations that it's made. And then what we could do is when anything's trying to grab this, we could check what's the current observer and we could like say, oh, here are some additional observations. And then the only problem with that is that we have, no, I think it makes sense. So what we're doing is there's no subscription here, right? So even though we're tracking these observations, there's nothing subscribing to it. So there's nothing here that's going to like re-evaluate it based on a change. What we'd rather do is when something tries to use this computed value, we have access to the current observer, so the component that's trying to access this. And when that happens, we're going to take the observations from this observer and we're going to add it to the current observer, right? So it basically, we just add observations to that component. And then when something changes, right, in those observations, this is going to run again. But how does it know? No, that's not going to work. Because we don't know if whatever changed was yeah, no, that's not gonna work. Thinking. So now we have the observations. And so what I traditionally think, the way I think about this is that we are actually subscribing, and then, but instead of every time the subscription triggers, it just flags itself as dirty. Maybe, oh, maybe that's how we can do it. So we are gonna run the evaluate here and start a subscription. No, we're not gonna start a subscription. That's the thing. We're gonna start a subscription when someone accesses this. And whenever the how are we gonna do this? God damn it. Oh, this is too much for me for a Sunday morning. We are going to start a subscription here. But then we can't dispose of it. Well, what we could do though is we could add the subscription to the current. That's also a thing. So if we have a current observer, that's a different way of doing it. It's not adding the observations. We would add a subscription. No, that doesn't make sense either. There's something about an observer subscribing to an observer. Ja? Bra! Hvorfor det? So in that mental model, we have this observer. It has its observations. Normally, a component is going to subscribe to that, but that's not the case anymore. Now we're going to have an observer that's going to subscribe to it. So what if, so for example, current observer, get current observer. So if we had current observer, what if we could say subscribe observer, and then we say observer. What's gonna happen now is that the observer is gonna subscribe to it with a notify, but when the current observer unsubscribes, it's also gonna unsubscribe any observers it's observing. And that's gonna notify whenever this thing changes. And then by keeping the last snapshot, okay, we're gonna try that. So let's see. We're gonna allow subscribe observer. Oops. Private observers. This dot observers add. Why are you observers? Add observer. And then we're gonna return. Sorry. Yeah, sorry. So now we're getting the thing we're gonna subscribe. Sorry. So we're gonna say observers subscriptions. So this is gonna be the disposer. So what we're gonna do, we're gonna say yeah. Observer subscriptions, add observer.subscribe, and then we have Yeah, but then we would have to do... Yeah, because then we get a new snapshot. Yeah, but I think we can just do... Okay, I'm just going to test it like this. So now we allow the component observer to subscribe to the computed. This is the computed observer. So we're adding a subscription to that here. And then whenever this thing unsubscribes, we're also going to remove all yes, we're also going to remove all the subscriptions of whatever observers we're observing. Yeah. I think this is going to work. And then the question now is how we... Yeah, so the final thing would be... So we're still going to do this. And then we're going to return, let's see, equals evaluate. Well, this is the thing. Like, we don't really want to evaluate until we actually need to. Does it, when I track, does it clear the... No. Where does it clear the observations? Does it ever clear the observations? Yeah, because it wasn't intended to be used multiple times. Like, this should be safe. Okay, so whenever we access the computed, we how do we do this? Because we're going to return a cache value if the snapshot of the observer hasn't changed. But that's not right either. Because if someone stops subscribing to it, we might be updating the underlying state, and this observer isn't being updated. Yeah, I'm not sure if it's harder to implement it. Ja. Jeg kan da snart. 2 seconds. I felt like such a remote control lately. Like playing games is more me navigating menus than actually playing games. So I'm doing a hardcore menu navigation course with our 4-year-old. Where were we? My intuition tells me there's something we can get working here, but I lost my trail of thought. The thing is that we kind of need to have that subscription going all the time so that we know when the computer is dirty, so that we know that we need to evaluate the new value. But that's the whole problem. We don't really want that. But if I'm not subscribing to it, how do I know if the values have changed? Or should the cache only be active while we have a subscriber? So whenever someone's not looking at it and then they're subscribing again, they have to, like, it has to be evaluated. But that's kind of, yeah, this is what I don't understand. Like, the computer needs to live on its own. It needs to know whatever it's observing changes. Ja. Nei, det får du gjøre senere, Oskar. Nei. And currently the observer needs to have an active subscription to actually track changes. But we don't want to have an active subscription, because that's a memory leak. But does the, oh my freaking god! Ja! Jeg kan heller gå opp til mamma. Ja, men da kan du gjøre det selv. Nei, du må gå helt tilbake. Der det. Her. Jeg jobber. Try to implement a computer reactive primitive while you have a 4-year-old playing Rocket League in the next room. Yeah, the whole point is that we need to we have this computer and it needs to observe constantly everything from the callback to be able to know when it's dirty. doing so, like, how can that not cause a memory leak? Because either it needs to be its own observer thing, like a computed observer. That's just always living. Hi, no, it's actually in Impact. How does it work there? Yeah, like, so for example, Impact, you can use, for example, Modex and stuff. But Impact also has this issue. Like if you use an effect, for example, and that effect is looking at parent state, you have to manually dispose of that effect, or it will stick around. It's a really tricky thing with reactivity. That you have this, like, that's the nice thing about components, right? They have a life cycle, but your state doesn't have a life cycle. Well, it implicitly does, right? By referencing. But you don't have any good ways of, except finalization registry. Like, it's possible to put yeah, what would you actually put there? Well, you could like put the object that the computed is attached on. Yeah. So as it's going through these getters, it could use the object that the getter is on as a finalization thing. So when that object can't be referenced anymore, it would dispose of the computed subscriptions. Maybe that is better. It's much simpler. Like it fits this model, because then the thing that's subscribing to the computed is the object the computed is attached to. And then unsubscription is basically, okay, we're going to try that. We're going to try that because it's much, much simpler. So we have this observer. You know what? This is too advanced for me as well. So we're in the same boat there. So we're going to drop this thing we added. Oh, let's drop that. So we have yeah. So what we're gonna return here is the observer. Subscribe. Oh, wait a minute. We can. Oh, wait. So there's a callback here. Maybe we should just put it directly into the proxy. Or we can just add it. No, let's add the target here. We don't care about what the target is. And then we're gonna have registry, new finalization, observer, Well, it's not going to be an observer. It's going to be dispose. Yeah, I don't have the typing for this. So this would be registry. Sorry. Oh, what did I do here? Let's just do this. So by just having that computed, we're going to start. Okay, equals evaluate. Yeah, and then we have to clean up. Do we do that now? Yeah. Clear up the observations. And then we're gonna observer.subscribe. And here we're gonna say, wait, but this isn't enough. No. No, we need. This isn't enough. We need both. So registry. What was the registry.register target, and then we're gonna dispose. And when we subscribe, we're just gonna say is dirty equals true, and then yeah, let's see, is dirty false. Yeah, sorry, this is not gonna be evaluate. Is dirty true. Return is dirty. Oh, well, if is dirty, value equals evaluate. Is dirty equals false. Return value. So what's happening now is that when we set up the computer, it has its own observer and nothing really happens, but we start subscribing to it, but it's not tracking anything, right? And then we register its target to the finalization registry so that whenever this target, which is the parent object of the getter, gets dereferenced, this should actually trigger. And what's gonna run is disposing of the subscription. So that's gonna clean up this whole thing. So we can add like a fake check on the observer itself as well. But what I'm wondering about is that it's not actually able to clean up, because this is inside the getter. I'm not sure if this is gonna work. Because it's not, no, this is not gonna work. Yeah, no, I don't like this. It doesn't feel right. How the hell? I've done this before. I think. But it's just, it doesn't make any sense to me. Because a computer needs to, you have to subscribe. Okay, what if you don't have to describe? What if you have an observer that's like constant? You track and you stop tracking, and whenever you track, you clear the existing tracking and then you stop tracking. And but that means that observer needs to live in the global space, like it is like an active observer. And the question is, when the hell do you remove that observer? So if we flip it around, we don't do anything. We have this thing here that's going to be called, and whenever that's called, we have an active observer, which is bound to the component that will be disposed properly. And then, as long as that observer lives, we're going to track. But how do you then cache it? That's the thing I don't understand. So as long as the observer lives, yes, we can make an observer subscribe to another observer. And then we could use the snapshot. Whenever this thing is accessed, we could check if the snapshot has changed. And then we will return a cached value if the snapshot is the same. But that means when it stops subscribing to it, the computer won't update anymore. So that means that it has to kind of become dirty again. But it might not. Yeah, this is what I don't understand. Oh, you know what we could do? So we have these observations. It's the whining, you know, the sound of whining. It's the worst sound in the world. It's the thing that it just takes all the energy out of you. Let's see. How the hell does this even work? So when I'm subscribing, so what the hell am I tracking? Nei, det må bli senere, Oskar. Okay, so we're observing targets and potentially their keys. Ja. Ikke nå, Oskar. Du kan heller gå opp til mamma. So when we start tracking, we're tracking targets and potentially targets with keys. And when we start subscribing, we are adding this observer to the global observation, so that when any of the targets change, it's going to be notified. And that's fine as long as this computed has a target that still exists. So does that mean yeah, and the problem is like during this this tracking, it's gonna add the target, right? Because you're deriving stuff from the target, so the target references itself, so it can't like work like this. It needs to be based on whatsoever is being accessed by a component. But if it's based on what's accessed from a component, then it won't keep up to date if nothing's tracking it from a component. If it was based on signals, yeah, I don't know. I'm kind of in a state where I don't think we're gonna actually solve this. I'm not sure how to fix this. It made so much sense what ChatGPT said, though. Many reactor libraries implement compute values that only activate, subscribe to their dependency when they have active observers. Yeah, but how do you keep that computed? Yeah, it cleans up its subscriptions, but what if those things change in the meantime and then a component tries to grab it again? It needs to recompute because you don't know if anything's changed. That's the thing I can't get past. Or maybe yeah, but I guess this is kind of the nature of it. Like you have to choose. Either you have to have it there all the time because it's literally observing. Observing state to keep a value up to date. And then we have this component coming along, which is also observing. And then it's like, hey, I want this computed value. Yeah, I'm always up to date, so here it is. Yeah, but maybe this is just the deal. If there's nothing looking at the ride, it won't be kept up to date. So that means whenever someone is coming in here to grab the the right value. But there's another problem as well, because now there can be like multiple subscribers here, and currently I only have a single subscriber to each observer, which is also an issue. Yeah, this fucking sucks. How do you do this? So we could just create a new observer for anything that tries to access. So what we can do is that whenever you try to access the computed value, we check if there's a current observer, which basically means you're trying to access it from a component. And when that happens, we're gonna create a new observer. It's like an inner observer. And that inner observer is gonna be created. It's gonna track its thing. And then we're gonna allow the current observer to subscribe to that observer. Which means that this inner compute observer has a subscriber. It's gonna notify the component observer when anything changes. And then that's gonna work. Ja. Du får ut det här så bra, Oskar. Det är superbra. Men det er masse igjen av dagen, Oskar. Jeg lover deg at vi to skal spille etterpå, ok? Du kan spille selv nå, og så kan du ta en tur ut med mamma, og så skal vi to spille sammen etterpå, ok? Men det er kjempekult å se fra mamma da. Du får jo dette så bra. Bra jobba, Oskar. Du får til det her, du. Oh my god. Oh my god. Oh my god. Oh my god. Yeah, but then the component reconciles. It goes to grab and compute it again. Bra! And now I just create a new one. And there's no way to verify if the value has changed or not. How would we do that? There's no way to do that. The only way to like I know we're not gonna. This is gonna be like 30 minutes of me staring at the screen, or an hour, I guess. Yeah, I don't know how to do this without creating memory leaks. It just doesn't compute in my brain. We want to have this like living thing without the ability to unsubscribe itself. Like, and if we tie it to the life cycle of a component, it means that it can only be cached for as long as that. Yeah, and like we're creating a new observer every time in a component as well. So that doesn't even work. So it would have to be some kind of observer reference here in the computed, which makes sense to me. That you have this observer that just keeps track of the thing, even then having this component thing subscribing to this observer. And then whenever it updates, it updates. The problem is we never know. The problem is when to reevaluate the value. So, well, there's two problems, but that can be fixed. So currently there's a single subscriber to an observer, but we can have multiple. We can have multiple subscribers. So let's imagine we have multiple subscribers. As long as there's a subscriber, it will notify those subscribers about a change, because now it's actively observing. But then it goes to 0. And it stops observing. And then we have... So there's this cached value. So to put it like this... when this thing... Oh, it feels like a different thing. Maybe we should change it. We should have not observer, but like a computed observer or something. Or maybe we should just inside here, we should have... Oh, wait a minute. So what if we have an observer here, but we also have subscribers? New set. This is going to be like, yeah, observer. This is going to be interesting. So if current observer, get current observer. So if current, if no turn well, maybe we should just return evaluate, and then if it's dirty, well, or if not is dirty, return value, something like that. These two are like connected. So this should really be a single state. State, well, let state equals is 30 true. We might have a value there. So this would be like is 30 true, value t, or is 30 false, then we definitely have a value there. Oh, sorry. State is dirty. Whatever. So if no current observer, we're gonna then like so. Let's see. And then if we have a current observer, we're gonna we're gonna subscribe current observer. Observer. Subscribers add observer. And then we're gonna return delete observer. What we're gonna do with the disposer here. Yeah, I guess we have to do current observer on dispose or something. Okay, something like that. And then we need to check if. Oh yeah. So this will be subscriber. And then if subscribers dot length size. Not observer. There should be subscribe. Sorry. Net disposer. What are you complaining about? Where's the disposer? Use before it's defined? What the hell do you mean about that? Oh, come on. Okay. The point here is that whenever we get a current observer in and we don't have one, like it's the state management that's accessing this derived, we're just gonna return evaluate. But if we have a component with an observer, we're gonna register a subscription to this computed, but we're gonna remove that subscription whenever that current observer is disposed of. When it doesn't. So we would need to have some kind of, so during subscribe here, we would have to like handle its own dispose. Private on dispose. That's also going to be a single. Well, no, that can't be a single one. Sorry. So this would have to be. Let's see. disposers, new set. And then on dispose. No, we're not going to delete those, but we're rather going to go through them here. Okay. We can rename this stuff. But now the thing is, now we need to notify without telling it a specific target or key. Okay, let's imagine we do this. And then we can just notify. Okay, this is interesting. Okay, let's just evaluate it. So let's fix this. Ja. Det blir senere I dag, Oskar. Okay, so we give the computed on observer, and then the computed has some subscribers, which are other observers, right? Component observers. And then we have a disposer. So why do we have this disposer? Oh, disposer. So whenever we hit one subscriber, we're going to start subscribing to this observer. And that means it's going to track the actual changes to state. But as soon as we reach no subscribers to this computed, it's going to dispose of that subscription and it's going to go kind of stale. And then yeah, sorry. And then so when we on the getter of the object, call this function, and if there is no current observer, we're just gonna evaluate. Now the problem is if there isn't any observer and we evaluate, we're kind of forced to run it. And there's like really, yeah, we shouldn't even do this. We should just run callback really. And this is the thing that kind of makes me don't like it. It's like, so if we're not accessing it through a component, we're not going to cache it. What? It feels like a bad compromise. It feels like a really bad compromise. So the thing is, what you would normally do here, I think, which works in like Impact, is that it's actually observing signals. It's not observing targets and keys. And it's mutable, right? So I can't really check it. Because what you would normally do is you would make the computed silent, but it would still have references to what it observes, right? So whenever something tries to access it and there's no active subscriptions, you could still go and check what it last observed. Has any of those things changed? But I don't have any references to that. I just have a bunch of objects and keys. Yeah, I'm not sure if this is gonna work. Ah, god damn it. Yeah, no, I have to think about this. This is no fun. So what if, okay, so from that perspective, I want to be able to have a non-observing computed to verify if it's dirty or not. And that means, so I do have all the targets, right? So this is what I have. I have observations, and these observations are targets and all observations. Yeah, sorry. Wait, what is these observations? Oh yeah, sorry. Is it a map? Yeah. So these observations are basically objects and whatever keys I'm looking at inside those objects. And it's not immutable, right? So I can't go through it and check if they've changed. I will kind of need to. Yeah, I don't like this. I don't like this at all. I wonder what. So are MobX computed memory safe? I wonder how they do it. Reference can. But how can the computer know when it gets dirty if it is not observing what it is computing? We work on they only track their dependency while they're being observed. When the computer value is accessed, it runs its inside the tracking call. Yeah. Those observables then notify the computed value when they change, making it as. However, when nothing is observing the computed value, for example, when the computer uses it stops tracking, in that case, it doesn't actively know it's dirty because it simply isn't doing any tracking until it's needed. Once an observer comes back, the computer. Okay. Yeah. It can, yeah, exactly. Reestablishes its dependencies, and during that setup, it can determine if any dependencies have changed. Okay. But that's also memory leak, right? So if it reestablishes its dependencies, so it basically means that it keeps its dependencies. What does it? What do you mean reestablishes its dependencies? Do you mean it runs the computed again, or that it has kept a reference to its computed values, computed and kept a reference to its dependencies? Like, I'm not sure if this is true. Like, we're asking an LLM about this. When the is accessed again by an, yeah, it reruns its computation. Yeah. Yeah, exactly. That might lead to memory leaks. Exactly. So that's actually how it works. So what this caching actually does is, as long as someone's subscribing to the computed, it's gonna handle the cache. It's gonna be cached. So it's kind of like use memo, right? As long as a component use memo, it's gonna be there. The only thing here is that it's cross components, right? But nothing's looking at it. It's gonna yeah, so even here we can check. So if we have subscribers, even that could be a state. Yeah. Okay, so we're gonna build it like that. We're gonna computed state is current idle or observing. And when it's observing, it might be dirty. True with a value, or current observing is dirty false. And oh, sorry, if it is dirty false, then we always have a value. If it is dirty true, we might not have a value. Yeah, hopefully this I didn't trick the LLM to tell me the wrong thing. Could you verify this with any web references? Okay, so a computer can be idle, which means that it just needs to, like, it can't cache anything, right? Because we can't, it basically means you're accessing the computed with no observer. But then it might go into observing mode because it's being accessed by a component that has an active observer. Oh. But there's a problem with this because we are unsubscribing to this observer for every reconciliation. Which means that this disposer we have, it's gonna run for every reconciliation. So we're not able to. That makes it even trickier. So we're not able to. We're clearing the cache every time. Yeah, this is not gonna work. Like, we have nothing. We have absolutely no reference for when this computer should be alive or not. I guess MobX observers, they keep the same observer running as a component reconciles and when it unmounts. But here it doesn't do that because of concurrent mode. Oh my god. OMG, OMG. So we have no way to cache it, basically. Okay, I have another idea. So what's possible to do is to take this other project we have, which is much simpler. Because instead of doing all this like observation tracking stuff, what it's doing, would that even work? Our 4-year-old is singing while he's playing Rocket League. Okay. So there is a way to handle this. And that is to have immutability in here. So what's interesting about that is we can do what I learned from that other approach, where we have a proxy that really builds up, which is mutable. So you, in your state management layer, you see them as proxies and they're mutable. But under the hood, it's building up an immutable representation of that state. And that state is what it emits to React. The challenge, though, is how would the observer work? So we would still need this observation layer. And we would have to track everything you access. Huh? But it feels a bit complicated. Yeah. 2 seconds. He's becoming proficient in navigating the menu. I'm very happy with my effort. Okay. Yeah, I don't think we're gonna start that project now. But what we would basically do is take what we have in the other proxy project, and we will build up an immutable version of the state. Because what you can do then is when you have computed, you can just look at the state. So basically, you or can you? No, because then you would. The problem is the references. Like the computed can't point to its dependencies. Or wait, no, it can't. It can't point to its dependencies because that creates a memory leak. Like it's such a. I'm gonna see if. When we say a computer reestablish it, we mean that every time it's accessed and therefore recomputed, it runs its function. Yeah. Yeah, but this is not gonna work. Not even with that immutable stuff, because we. Yeah, but maybe it's just fine then. Like, why not just use? You can just use MobX. Why go? Like, this has been an awesome learning experience. The thing that bothers me with MobX is that it exposes like some like reaction and stuff. Which I don't think you should use for state management. But yeah, no, it would be, you know what? It would be much better to make Bonsify. Okay, we're going to try something. Clean with MobX. So the whole point of Bonsify is the pattern, right? But you have to have some reactive primitive. And it's easier to do that. So let's just add MobX. Wait, what is it? MobX React Lite. MobX React Lite. I think that was deprecated. No. MobX React Lite. Oh, come on. MobX React Lite and MobX React Lite. The whole point here is to simplify state management. It's not to reinvent observation. This is what it takes for me to get to a conclusion, Adam. You know what? We're gonna do this. We're gonna delete everything here. Prox. Else guy. Ja, men det blir senere i dag, Oskar. So we're still gonna call it reactive, but we're gonna import observable from MobX. We're gonna add MobX, of course. Because observable, that's the one that also does that one convert auto. Well, the problem with MobX. What we could do though, we could keep that read-only proxy. Yeah, because that's the thing I don't like about MobX. It's the actions. Actions are horrible. Okay, we're gonna try something. Creating observables. Observable. Does this? Oh. Huh? Yeah. 2 seconds. Da kommer du tilbake på hovedmenyen. Nederst. Ikke der. Garage, DMG. Bra, da har vi kontroll igjen. Let's see. So, we should not have this action thing. How can we make options? To override, what's the options? Can I make it auto do this except for actions? How do I do this? Object return will be a proxy. Available annotations. How do I fix this? I wanted to make. I could just go through it myself. Make observe. I'm used to make it energy, including a. Methods that deriving from an taken, for example. Ja! Hæ? Ja, det er timet. Å ja, var det en kamp? Ja, du må ikke gå fra kamper, da får du ikke lov til. jeg har gjort det feil. Ja, men du må vente en halvtime. Så må du spille mot dataen. Her. Skal vi gå tilbake. Nei, nå gikk det. Å nei. Å ja. Du må spille mot dataen, eller... Vet du det? Gå tilbake, så ned på blå. Oh my god. Okay, so what I want to do is but maybe this if I just turn off action, does it stop? All functions become auto actions. Oh, all setters be auto action. What the fuck is an auto action? They have this is the point. Like MobX is such a beast. It doesn't have to be this complicated. Where auto action? What did it actually? Auto action. Oh, there we go. No, that was my search. Was it? What did it jump to? Okay, I have a feeling that I just wanna... Okay, we're just gonna try it. So what's this? Is it configure? Force actions never. So I just assume that it's not gonna do anything about that. And then we're gonna do this read-only thing instead. So that actually means we shouldn't have deleted our proxy. Let's go find it. Source proxy. Let's copy that. Oops. Read-only proxy. So we're not gonna have... This is gonna be interesting. Yeah, exactly. But you do allow to change the state from components, which is fine if you're one person. But if you're a team, and not everybody is perfectly aligned with that. But yeah, you can still choose it here, right? It's just you do it with the read-only thing. So we're gonna remove that one. There's a lot of stuff we don't need here now. Yeah, sorry, I forgot to say that. And it's awesome. Wait a minute. Create array proxy. Okay, create base. Wait a minute. What's all this stuff? Oh, how do we clear the read-only cache? Ah, god damn it. There's obstacles everywhere. Damn it. Oh, wait a minute. This was related to immutability, wasn't it? Yeah, sorry. No, this is fine. Let's see. Let's just keep. We don't need to notify observers anymore. We don't care about mutating array methods. We don't care about this proxy target thing. We don't need any of this stuff. Maybe I should just. Well, we care about the mutating array methods. We do. But we don't care about the iterating ones. We don't care about this. We don't care about this. And we don't care about this. But we do care about this. You cannot set anything. We care about that, and we care about delete. And like that. Boop, boopity boop. And we have the array proxy where we don't. Well, I think we should just do. We don't care about this. So this is the. There we go. We override the mutation. And then we don't care about the iterating stuff. And there's only create proxy now should always be like this. Because it's always read only. We don't have this stuff. 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 Read only. Wait. Oh, proxy cache. Proxy cache. We don't have this. We don't have this. Proxy cache. We don't have this. We don't have this. We don't have this. Oh, I don't care about this. We don't care about this. I don't think we even care about. Okay. Let's keep that one. We don't care about this. Okay. Slash create proxy internal. I don't think we're just calling that from create proxy, right? Yeah. Let's just move that. Okay, cool. Yeah, exactly. So this is the base proxy handler. We don't have to pass anything into it. There's no targets. Oops, there's no read only. Okay. Yeah, same here. Cool. So what we are going to do now is go over here and we're gonna have create proxy. Yes. So we're not gonna have actions, but we are gonna allow you to say this part of my state is read only. I think that's such a better model. And we have this single reactive. There's no computed nothing. It's just when you use a getter, it'll be a computed. The observation is going to be is automatic based on the plugin. It's like just a simple, it's like MobX Lite, right? It's MobX Lite. And then instead of classes, you have a functional way of approaching your state management that removes the overhead of all the keywords and disk bindings and everything. It's a pure joy to work with. And now we're also come to my mental place of thinking about this as this is, you embrace completely your state management is very much tied to the UI you're trying to build. And you're going to derive as much as possible for the UI in your state management, because there it's going to be cached, optimal, and it's going to be out of the way of React. So when you MobX Lite. Yeah, exactly. Yeah, and it's out of hands of, and your components is going to be super simple. So that's one edge case frame of mind that makes a lot of sense to me. And then the other one is like embrace the React compiler, do everything in React. What does that look like? That's the other edge. That's the thing I wanted to get to, because we have this insane ecosystem of mix and matches in between that I want to avoid. Or is there a way to like not have to do that? Okay, let's build it and try it. And let's see. We have this counter. Oh my god. Okay, let's just build something simple. Let's see. App. Yeah, not reactive. Yeah, we're not gonna have these utils. Just gonna have a counter. Okay, let's take a look. So we're gonna export function counter. Const counter. Oh my god, I do that very often. Counter equals reactive. Yeah, and then for some reason that's just not from Bonsify. So we're gonna have our count 0. We're gonna have our increment. Hei du, går det bra? Du, jeg så stolt av deg at du klarer, kan jeg få en? Jeg så stolt av deg.
Men var det ikke så stort? Ja, skal vi starte med den?
Ok, takk. At du får til å spille og styre selv og ordne opp selv, jeg synes det kjempebra. Men pappa blir så glad når jeg får lov å holde på med litt med mine prosjekter også. Og så det masse igjen av dagen.
Kan du være med meg nå?
Men har du snakket med mamma om å ta en tur ut, eller?
Nei, jeg vil bare ikke det. Fordi jeg har ikke det. Så jeg vil game.
Jeg skjønner det, men nå har du jo gamet veldig mye.
I går, det var hun.
Hæ? Emma var ute, ja.
Nei,
Jo, hun var hos Line.
jeg vil ikke hjemme.
Men du, Oskar, vi sier stopp til gaming akkurat nå, for nå har du fått game masse. Og så må vi en tur ut før vi gamer mer. Nei, langt ifra. Langt ifra.
Det må bli en liten detox i på.
Mm?
Jeg tror ikke du så noe game mer.
Etter.
Jeg har gått ut.
Ja, senere i dag, ja, så kan vi to spille mot verden sammen.
Vi gjør det nå.
Ja, men nå er jeg superlykkelig. Nå har jeg fått sitte her og for vi må ha noen dager det bare er sånn. Hvis det går an å få til det, altså innimellom når vi er utslitt, at han kan bare sitte og game, så må vi gjøre det. For det er helt fantastisk. Nei, det er på, ja. Right, let's see. Increment, counter, count, plus, plus. And we have our counter. Nei, ikke nå. Nå må du ut en tur først. Mamma kan bli med deg ut en tur. Oh, look at this. Did I actually have... No. One click, counter. And this is another good thing, is that you can reference functions without thinking about bindings, this binding. Look at that. And it just works. That's nice. And that's basically it. Let's try adding the reactive proxy read-only thing. And if I try to... Let's do something fun. Try to change it directly. 1, 2, 3, 4, 5. Oh, it still mutates it. Why does it do that? Oh, of course, because I'm actually incrementing it as well. This would be the proper way to do it. 1, 2, 3, 4, 5, and then it stops working. Nice. And you can do this at any level in your state management, right? So if you have nested state, you don't want that to be changed by parents' state management. You can do the read-only thing there as well, which is nice. Yeah? Okay, but I think this is this was a nice conclusion, and I'm gonna play around with this branch and update the documentation. In that context, and then I want to try to make a video. Well, that video has to be when the React compiler becomes a thing, but we should continue the refactor of the other app where we use the React compiler. And then we have these two... Nei, du må ut en tur først. Nei. Jeg har sagt nei. No. And yeah, and then we can use that as a reference. And then the goal is to kind of say, instead of having like 25 different choices, you really have like on each end of the spectrum, you really have like, you have each end of the spectrum. You have embrace React, but you need a React compiler if you're going to do to avoid performance issues. and to just write nice code, right? You don't have to use callback or use memo or anything. You just write code. You just write React and you just write JavaScript. And the React compiler allows you to do that. And then on the other side of the spectrum, you build your app externally and you treat React as just a view layer. And you do all your state management and derivation and everything there. And then, but that is ultimately the most performant thing to do as well. Yeah, I like that. And then if I'm in a company with a team and just, okay, what do we feel like? Do we think we should have the mutable thing and that's where we build our app? And do we like that paradigm? Thumbs up, it's also going to be the most performant. Or don't we want to do that? Then let's just embrace React and use the React compiler, and then we should be happy with that as well. Yeah, I just want to be happy. It doesn't matter that much if I'm embracing React or the other thing. It's the stuff in between that puts me constantly out of balance. I still wish we could find a way to base a part of the tree at a point in the... Yeah, you mean like create nested state management as part of the component tree? Like the thing you show me, where you instantiated like a class and then dispose of it when the component unmounts. Making that assumption, yeah, the only thing, like, you can do that, like, yeah, and that's exactly what Impact tried to do, right? But it used the context to do that, which is like, yeah, because then, but the problem with context is, like, we've been talking about props contracts. So that's a bad thing about Impact, is that it doesn't create a strong contract. So, like, just having a use reactive, right, in this context, that you could just shove into any component. Like, you can do that. The problem is if that thing starts having side effects. Yeah, and I agree. Like, there is definitely something about kind of fusing the two as well. So for example, in Family Scrum, we have this session, and when you're authenticated, that's when you kind of have the actual app, but it doesn't have to be like that. We could have like a session thing that only moves you into authenticated, but then the component that renders when you're authenticated, that's the thing that fires up Family Scrum, right? The state management of Family Scrum. I agree that should at least be an opportunity. The only problem is like disposing. So Family Scrum fires up a bunch of subscriptions when it's created. So one part is like, you can't do strict mode because it will fire up 2 Family Scrums and will fire up 2 sets of subscriptions. And as we talked about, you can't like dispose of the other one in strict mode, and there is like a theoretical risk with concurrent mode. It's very annoying. It is very annoying because in practice, it works just fine. Oh yeah, interesting. Yeah. Yeah. No, it is very interesting. But it's also like if you are embracing like external state management, you might as well also just have an external router. So it has like what page you're on and everything. It still like mix and match that makes things tricky. So like if you mix external state management with React Query for data management, for example, it gets tricky. If you mix external state management with React Router, it gets tricky. Oh yeah, it's not repeatable. Yeah. Oh yeah. Yeah. Yeah, it is. Yeah. But would you, if you imagine like not having that router there, you would actually have a router as just like a environment thing for your state management. So you would rather like have state that represents each page of the app. And then within each page you have your state management, and then you just have current page. Oh, you do that for routing. Yeah, but some things are still sometimes driven from in the components. Yeah, you mean also the kind of you're opening a form and then you want to kind of dispose of the form kind of thing. Yeah, like it's a beautiful thing, the lifecycle of a component. Having things driven by that lifecycle. It makes a lot of sense. And that's a huge benefit embracing React. It's like everything's just driven by a lifecycle. While in external state management, there isn't any lifecycle. You're manually handling everything. That's the downside to it. Yeah. Yeah. Yep. Like, okay. Like, otherwise you get base page init, which calls subpage init, which calls subpage init to ensure the state is done before the component renders. Mm-hmm. Yeah. Yeah, so like there's okay. I can write some code on this. So for example, if you have like your app, and then the freedom you kind of have is reactive. So you have pages, for example. So what you would do here is like maybe have like a dashboard. Let's just use Family Scrum as an example. So you have dashboard. Oh, come on, a dashboard. And you call the dashboard. Like you can initialize everything. Like okay, settings, profile, whatever, right? And then you have current page is like dashboard. So this is the only thing you really need in a component, is to just switch on the current page. And then you kind of, well, you can just call it page. And then you do like pages, page, and then you always have the state there. Like the state lives always. But you can choose to change this. Like you can have, what's it called? Yeah, like page is the actual thing, right? Dashboard. And then you have like set page. And then you flip through, like you get like whatever page name, whatever. And then you say like app.page equals, and then you have some lookup pages name, and you call it, you instantiate it. And then you clear the state every time you flip the page, right? Just having that previous version is really, really nice. It creates like an insanely snappy experience, right? So when you're flipping between pages, all the state is already initialized. It's just rendered the thing, right? So being able to do that, and then the tricky thing is actually, yeah, exactly. So yeah, just to finish that. So the tricky thing here is to bind this behavior to a router, especially like nested routing, for example. It gets a bit more trickier. It's not as straightforward, but you still have the flexibility to state can live way beyond the routing, right? It's not coupled together, which is super nice. But anyways, yeah, so here you would have like dashboard, and then dashboard is reactive. Dashboard, and then dashboard has like its own settings. So you would just nest it like this. Oh yeah, so you mean, oh yeah, so each like, so you're still on routing, right? So you're trying to like, you kind of have nested routing, right? And it's tricky to bind that to this kind of structure, because as you say, you have to kind of do the switch at every level to figure out what's like active. Yeah, I can't remember how we did this in didn't I yeah, exactly. Like the result of it is amazing, right? Because you have full control of when your state actually lives. And typically it should just always live, right? So when you flip between UIs, it's just instantly there. You can have subscriptions running in the background, always keeping your state up to date, and it's like no biggie. And you can also have one page can interact with state of a page that's not even active, right? And it's just ready when you get there, kind of thing. I'm trying to remember. I had this router, type client router. It does exactly what you expect it to do. It sounds like something I would write. I've mostly been working with editor types of experiences, single page applications where you want as much control. Hei! Det var på Bleis. Går det bra? Du, Skulle du ta en tur ut, eller?
Nei, jeg skal bake kjeks nå.
Skal du bake kjeks? Så koselig, da. Får jeg smake etterpå, eller?
Ja, vi skal bake mange kjeks. Så må jeg få.
Ok, men skal du bake litt kjeks, da, så kan vi to ta oss en tur ut etterpå.
Ja, på trampolinen.
Ja, få ta en tur på trampolinen. Jeg vet ikke om jeg får poppa noe selv, da, for jeg har så mye snørr i nesa mi.
Da kan jeg stoppe, og så kan du snyte deg.
Ja, vi får se, da. Men vi tar oss en tur ut, i hvert fall. Kos deg med kjeksbaking, da.
Du kan få det til pappa.
Yeah, exactly. You know all the dependencies. By the way, I'm going to turn off this disco. There we go. Okay, I have. It's a long time since I did this one. Has anyone? Does it have? Oh, it has 6 stars. One of them being mine. I've stopped doing that. I've stopped starring and liking my own stuff. So such a narcissist. Single page applications where you want as much control as possible on the routing experience, but still be able to define routes explicitly and react to when changes occur. Changes are path changes, not query changes. What the hell do I mean by that? Oh, I think this was a retaliation against Next.js. Because they have this object called query, which holds path information, which pissed me off. This router does not treat your queries as a reactive state store. Yeah. This was because of Next.js. I was pissed at Next.js. I wonder how many open source projects I made because I'm just pissed at using something else. They are there to optionally give initial state, and you can keep them in sync as your application state changes without worrying about performance issues. This router does not affect your anchor tags. That means you cannot expect anchor tags with just an href to automatically work. It can be a good idea to create your own abstraction around these elements. See below. Okay, so here, how does this thing work? You create a router, and here I show like the nested thing. Optionally provide a base path. Yeah, so this takes, it's really cool how it works, because you can see that yeah, where is it? Yeah, so you see like you have params ID because you have like ID : ID here. It's kind of cool. And then you have queries. You can set the queries, and you can listen to the route. Yeah. So, okay, I didn't remember how exactly I did nested things here. So, the way you could bind everything to this router is yeah. Do we have a good example? So you have a to-do list which gets loaded from the server, but each to-do has many different ways it could be rendered. Imagine a to-do type. Based on this type, you render based on the data. Fetch for each to-do. So the server decides how to render it. It's part of the to-do data. Yeah, it has a type, and based on the type, you decide how to render it. Just to continue this, this one. Yeah, so like the way this would work in the, and each type could have its own component. And oh yeah, I see what you mean. Yeah, so you want, so you at some point you see how nice it is to like couple components with state. But it works fine as long as that state doesn't have to dispose of anything. What if you so one idea is, let's say you want to do that, and you can do that. You could even like you could use a ref, or you could use a use state with callback even to create the state. But you can also have a nicer like user reactive, which you pass a function and then it like handles it for you. But instead of actually, var det? Ja?
How good can you
Ja, men jeg er så forkjølet. Men ellers takk, Oskar. What if you say that these can't, you don't, yeah, but what if you rather said this? So you're in this component, let's call it like to do whatever, and you do have your parent state here, right? So you have something like to do's or whatever, which is part of like your root state management, right? Does this make sense? I'm not sure if this makes sense. Well, what I meant to say is like you could do something like to do use reactive, and then to do, and you could pass in like to do's, for example. Anyways, what I meant is a parent reference. So you don't expect to dispose of this to do. What you would rather do is that you would rather say inside to do, inside to do, you would have like, I'm getting my to do's here, and then I would say to do's. Yeah, maybe this doesn't make any sense. Yeah, no, it doesn't make any sense. The thought was that you would not dispose directly on to do. You would rather register anything you need to dispose on the parent state you pass in. But there's nothing wrong with like you could probably do something like to do. But the point there is that you need to dispose of stuff, right? Because you can like do get view or like render or something, and then you just like do this. So you just put your component in the, don't even have to do that. Could even be to-dos, and you map over your to-dos, and you just say to do dot component. But then you're putting like React inside your state management. But yeah, is the point that you need to... Oh. Integration. Oh, so you're getting a bunch of integration data. Yeah, and then from the outside, you're initializing. Oh, this device data. Oh, sorry. I didn't read the rest of the. And init device data gets called from the component, like snippet. Use timer effect. False props. What's the idea here is like you want to initialize device data based on a timer. Yeah. Oh, that's what you meant. Yeah. So what's the... I'm just composing everything in my head now. Is this... How would you want to do this differently? Yeah, exactly. New... Oh, yeah, so this is not... Oh, I'm trying to read the code here. No, yeah, because this is a callback, right? Yeah. So every 5 seconds, it runs this callback, initializes device data. Yeah, so it's basically you just want to... So the thing is you just want to initialize state based on usage in components. Oh, yeah. So kind of like this generic data thing. This lives in your store, right? This is the store, I guess, because it's dot integrations data. Yeah, and then you have store. Okay, so this is the store. Yeah. And then this is kept, right? When you navigate away. So when you get back, yeah, you see the stale thing, you do the get state, and then it updates. Yeah, okay, I get it. But is there information in the component that doesn't exist in the state store? Or is it just that, like, it's just a hassle to, like, set up this timer effect? Or, like, well, where is this like a list or something? Is there a list of devices? And then you pass each device into a component, and then it sets up this, like, its own, like, nested state of generic data, device data. And then you kind of want to run that as long as a component is shown, but you don't want to run that when the component is not shown. Yeah. But what I think I would maybe have done here instead is so what decides when there is a device? Like, is there a reason why you're not creating the device data just immediately? So when you have the integrations data, that you're not creating the device data as well? Or you just want it to be like dynamic? Because one interesting thing here is like what I'm thinking about is like you could have a use effect that would subscribe. Like if you think about use effect as a subscription, what you can do is that like you have the device data already. And then what this component does is it will never have device data null. It will always have the device data. But then you can subscribe on that device data using just a use effect. Yeah, like exactly. When should it be created? Exactly. Yeah. Yeah, because now, yeah, exactly. So here it's like you have these devices, you have a component that maps over those devices, and then you have a component for each device, and it's responsible for creating this generic data device data. Are these real domain names? But But you could argue that when you get the integrations data, you would also like just map over all the devices and create the generic data, device data. But I also see you have like props.within. Maybe that's coming from somewhere else. So I kind of see that. But I guess you would also want it to be cached, right? So yeah, so what you can do, okay, so one thing you can do. So what you can do is, that might be an inspiration, is class, let me just copy this. So instead of init device data, what you do is you say get device data. And then you say if, and then, well, let device, it depends how you want to do it, but yeah. So you have the device data and then if, oh, sorry. Yeah, I guess you know where I'm going with this. So you don't think, like you would typically think about it as initializing, but it's also a cache, right? So you can say get device data and then if no device data, device data equals this dot device data ID equals new generic data device data. And and then you would do like, I guess this device is whatever, you know what I mean. So this is kind of like how you would do promises as well. Well, that's out of context. But yeah, point is that don't init, just get it. And if it's not there, create it while you're getting it. Because then in the component, where's the component? Yeah, so in the component, you could just do function device. Now you can safely do it at render time, right? So you can say store device equals store get device data and then props.id. Now you have it at render time. And then you could also do use effect device dot, I guess you could even, yeah, sorry, subscribe, like that. And then that subscribe would hold the like complexities of all of this. You wouldn't have to like have all of this stuff. Well, it depends. Maybe this timer effect is some generic thing that's nice to have, but you could have like a simple subscribe to the device and then it has access to all the specifics of the device and then it decides like how often you can do the thing or whatever. Yeah, question is what do you do? Yeah, and you can just subscribe to it, right? And then it will update the device data. Får jeg smake? Å, tusen. Jeg bare tar fingeren sånn, jeg tar bare en liten. Å, jeg gleder meg.
Kan vi ikke gjøre noe?
Mm?
Det er så snill.
Nei.
Pappa, jeg kan ikke gjøre
Men du holder på å varme. Steker du kjeksen nå, eller?
Ja.
Det er bra, men det blir fort ferdig da. Skal vi bygge litt Lego først?
Ja.
Ok, jeg skal bare avslutte.
Men Viken, det er ikke i noe tid.
Ja, men vi må ut en tur først.
Hvor lang tid å jage?
Ja, men vi kan bygge litt Lego, så tar vi en tur ut. Mm. Yeah, so the point is, you're just getting the... Yeah, I guess I just explained it. Does this make sense, Adam? Well, you can dispose, because this device subscribe returns a disposer. So you're unsure that as long as something is looking at the device, the timer will run, and then it will stop the timer when the component unmounts. And you can have multiple components subscribing to the same device, and then when the length of subscribers is 0, that's when you dispose of the interval. So I guess it's a way to think about subscriptions inside your state management. Yeah, maybe this is a nice pattern. Like instead of initializing something in your state, you're just getting something from your state. And then if that has a side effect, you have to subscribe to that thing to trigger the side effect. And then as long as it has subscribers, it will be running that side effect. That's cool. I haven't thought about this. But it could be an actual pattern. Ah, I'm happy. Yeah. Okay, I'm gonna add that to the Bonsify thing. Like the apps you've been working on, Adam, is just amazing for talking and discussing state management. Hæ? Ja, jeg avslutter nå. Jeg holder på å avslutte nå. Ja, jeg skal bare si ha det, og så skal jeg skru av, og så... Oi. Er du klissen? Det går bra. Men du, kan du være sånn ikke trykke på den? Okay, I have a very impatient... Du er full av... Yeah, but this is very... Yeah, it's just amazing having these examples, Adam, because this is exactly the types of applications. I think you work on even more like complex state management. Well, maybe it depends. Like I've had some really quirky asynchronous stuff that I've been working on, like commit flows and stuff like that. Which is like partial, like git status and all that kind of stuff. It's very tricky with auto suggesting commit messages and stuff. But this is like data complexity with subscriptions on individual like nested pieces of data and all of this stuff. So it's very, very interesting. But yeah, I'm happy we got to this pattern. I'm gonna definitely document that in Bonsify. And this is exactly what I want that project to be, right? It's embracing this model of do your state management outside of React, super optimal. Don't think about observation in the components, just expose your stores. And then you have this like very simple approach, just using patterns, not a bunch of abstractions. And you can, like there's a class variant of this, but there's also a functional variant of this. And then you can drive the class-based thing, and then I can drive the functional thing. But it's the underlying patterns of how to organize all of this stuff, right? That's the important thing. That's the value. It's not having like super duper data fetcher collector thing with like 100 different options. Oh, okay. Cool. I have to go. It's getting very impatient. Bye for now. This was awesome. And I'm so happy I was able to actually do this. Okay. Bye for now.